Hello again. Here we go. We're going to look at graphing. It says graphing an equation by plotting points. So what we need to do is we need to take an equation, and I've just picked this equation, y equals negative 3x plus 4. Right? We're going to plot some points, and we're going to put it on a graph, and then we'll have graphed our equation by plotting points. A couple of things to remember. Okay, this is the slope. The slope is negative 3. The y-intercept is positive 4, but we're not going to use these for this. We're actually going to plot points because that's what it's asked us to do. To plot points, we need some x values. This is called the independent variable. We get to pick them. I always like to pick 0 because it's an easy one to substitute in. I tend to like to pick negative 2 and positive 2. Those are the ones I tend to pick. Negative 2, 0, and positive 2. You can pick any numbers you want for x. If you pick those numbers, then you have to find the y's. But it will always work because in number theory, lines go on forever. And all a line is a series of points. We'll talk about more of that in a second. So what I do is literally substitution. And you see it on the slide. So I'm going to do the simplified version. I'm going to take negative 2. I'm going to put it in for x. I'm going to find out what y is. So I'm going to put negative 2 right in there. Negative 3 times negative 2 is 6. 6 plus 4 is 10. That would mean y is 10. Okay. Then I'm going to use 0. Okay. I'm going to put in 0. Instead of the x, I'm going to put in 0. So negative 3 times 0 is 0. Plus 4, 0 plus 4 is 4. Okay. And then I'm going to repeat it one more time. I'm going to put in the 2. Okay, so I'm substituting this value of 2 in for x. Negative 3 times 2 is negative 6. Negative 6 plus 4 is negative 2. And what I've got then is I've got 3 points. See, they're x's and y's. So I can turn them into points. Negative 2 and 10. 0 and 4. And 2 and negative 2. I've got 3 points. I can plot those 3 points over here on my Cartesian plane. Negative 2 and 10, so I'm going to go over to negative 2 and up to 10. I'm going to be about right there. Okay. Now if I had graph paper, of course we could be far more exact, but graph paper on a whiteboard doesn't work so well. 0 and 4. Okay. 0 means I don't go left or right. 0 and 4 means I'm going to be right here. Okay. And 2 and negative 2, I go over to 2, I'm down to negative 2, kind of looks like I'm going to be right there. Okay. Now, what I can do, I can take my fancy ruler here. Whoops, moved on me. I can draw my graph. It didn't work so well with the blue. Let's try doing it with the red. See if we can get something better here with the red. There, hopefully you can see that better. Okay, and I got my graph. Notice that the graph goes through, oh, my blue is dying. Notice that the graph goes through this point, and this point, which are the 3 points here. And that's how you turn an equation into a graph, okay? And why you can pick any point, this continues, and this continues. So why you can pick any point and you don't have to pick the same x values that I have picked is because, let's say I picked negative 3. Well, if I go over to negative 3 and I go up here, it's going to touch. We'd have to extend it. Or let's say I picked, let's say I picked 1 for x, right? If I only went over 1 for x, I could find out where it touches. So it will create the same line no matter what points you pick for x. You don't have to pick the same points I picked. Having said that, negative 2, 0, and 2. Great numbers to pick because they work really well most of the time. Right? I hope that makes sense, and we'll see you at the next video.